All right, welcome everyone. We are live. Hello. Welcome to another ASP.NET Core Community Stand-Up. I'm Daniel Roth. I'm a Principal Product Manager at Microsoft on the ASP.NET Core team. And this stand-up is all about engaging with you, our wonderful community in the .NET ecosystem, about the latest product developments that are happening in the .NET platform for ASP.NET Core, for .NET Web Development, for Blazor, for Aspire, for all the things that are happening with server-based development with .NET. We have an awesome topic today that we're going to be talking about. We're going to be talking all about building MCP servers with ASP.NET Core, some of the latest advancements in extending existing AI models to do what you need to do to get the job done. We have a whole crowd of guests today to tell us all about building MCP servers with .NET. So let's get everyone introduced. Who wants to go first? Mike, do you want to introduce yourself?
Sure, I'll kick off. Okay, good. I'm not muted. My name's Mike Kistler. Been here a number of times before now, but now I'm here talking about a new topic, Model Context Protocol. This is something that we just started doing in the last couple of months. Really exciting stuff, and we're going to tell you all about it.
Awesome. Welcome, Mike. Sam, you want to go next?
Yeah, I'm Sam. I'm PM also on the ASP.NET Core team. I have been looking at diagnostics with MCP and seeing how that can accelerate the AI use in our diagnostics scenarios.
Yeah, real world use of a new MCP server sounds exciting. And then we got Stefan as well. Stefan, say hello.
Hello, I'm Stefan. I've worked on ASP.NET Core for a long time, and now I'm working on the C# MCP SDK. Excited to show off some demos.
Fantastic. And then we have this other guy. I don't know who he is. He just sort of joined. John Galloway, welcome.
Hello. Happy to be here. I'm a PM on the DevDiv community team, and part of my thing is I'm supposed to focus on AI. So I figured, hey, if I'm here, I get a front row seat.
Fantastic. Yes, you do. Yes, you do, John. always open for you. We always have that seat just there and available for you to join us. So just a few reminders. If you have any questions during the stand-up today, feel free to put them into the chat wherever you're joining our live stream from, YouTube, Twitch, and so forth. We will try to answer those questions as the live stream goes on. The whole point of having these stand-ups is to engage with you, to find out what do you think about the investments that we're making in the .NET platform. How can we make things better? How can we better handle your scenario? So feel free to post your questions there. There also is a URL list link with related links for today's stand-up. A couple links related to Model Context Protocol. What is it? Links about the C# SDK that I'm sure will pop up during the presentation today. So be sure to check out those additional resources. And with that, I think we're going to go ahead and get it started. Mike, I think you're going to start first. Is that right?
Unmute so I can, yep, I'm going to start. And thanks for showing those slides, John. So we're going to talk today about Model Context Protocol, and specifically Model Context Protocol for C# and .NET. So we've already done the intros. We can flip to the next slide. Just a brief about what is Model Context Protocol. This is the protocol that was developed by Anthropic. It's actually now being adopted by many other AI players as well, like OpenAI. But it was developed to enable LLM applications to integrate better with external tools and data sources. And basically the problem that they were trying to solve was that an LLM often is trained on a specific corpus of stuff up to a particular date, right? And then after that date, it doesn't know anything about what's gone on in the world, right? And so some of these tools that you can provide give the LLM the ability to bring in new data, be able to query external sources, right? And find out all this information and then be able to integrate it into your LLM application. So there's a specification that's linked there. This is the 2025-03-26, relatively new specification. There was one that was actually released in November that we were working towards for a while. But this is the newest one, and it is evolving rapidly. So I expect there's going to be another one, an update in a month or two, because there's already a lot of discussions about things that should be added and updated and things like that.
So I know, like in the past, like if you had an AI system, you would often extend your, like if you're building an app, like say with Blazor or aspnetcore, and you plugged into like using Azure OpenAI, one of the AI models, you could like do the retrieval augmented generation pattern, right? Like you could expose data to the model through some like a function or a tool that the model could then call into to get that data, and then do things that were specific to that data in your app. So how's the MCP server different? Like I guess this would be like you want to plug into, it's not your app, right? Like you're plugging into someone else's app that has AI integrated, like Visual Studio Code with a GitHub Copilot or Anthropic, like those types of things.
Yeah, I'll show you that. I'll show you that in a minute. But I guess just real briefly, I'll say that with retrieval augmented generation, the way that typically worked was you would have a database where you would do a semantic search and you would get a bunch of information, and then you would stuff it in the context window, right? And you would pass that to the LLM and say, this is the most relevant information that you need in order to be able to answer the questions that I'm asking you, right? And as you said, Dan, there's this ability for LLMs to make function calls, right? And that's really what MCP is leveraging, where it's not putting the information in the context window, it's putting information in the context window about how to get information, how to use these tools in order to access the information that you need.
Yeah.
So we'll get to that. We'll get to that. So let me just talk about some of the key abstractions. The first one is what they call the host. This is the LLM application. This is something that somebody's building, and you can build these in all kinds of languages. And with our new C# SDK, you'll be able to build these in C# as well. There's the concept of a client, and this is the link between the host or the LLM application and an MCP server, which is going to provide all this additional context and resources and tools. And then the server provides that information, and there's lots of things that it can provide, but the three key things that we'll talk about today are tools, and these are functions that we can provide to the AI, to the LLM to call so that you can get back information. There are prompts, which are either static or templated prompts that you can pass to the LLM to get information. And then there are resources, which are sort of static resources, web pages perhaps, that provide information. Okay, and I'll demonstrate all of those here in a little bit. Okay, next slide. So there are some key principles that Anthropic used in developing this model context protocol that I think are important to keep in mind. There are a number of them, but I've called out these two in particular. Users must explicitly consent to and understand the data access and operations. So we don't want the LLM to just go off and accessing all kinds of data. Likewise, we don't want MCP servers to be just going willy-nilly accessing private data of the user, right? So there's this very important concept that we have here in the MCP protocol. Let me just say the second one: users retain control over what data is shared and what actions are taken. And the whole idea here is that there's a human in the loop, right? The human gets to decide what data flows either to the server or to the LLM, right? And is in control at all times. And you'll see some of that as we go forward. Okay.
So this kind of feels to me like when my phone pops up and says, hey, I would like location services, or I would like to use your camera. So this feels like that's applying that sort of thing to what had been kind of unstructured in the past with like retrieval augmented generation or that kind of thing, right?
That's right. That's right. That's right. It's very similar to that, John. Yep.
And I will say, like, the specification for MCP calls out that a human must be in the loop, but it's on the consumers of the SDKs, the client and the server, to implement that. So
right,
it's a thing that you ought to do.
But all the mechanisms are there to implement it. I think it's
of course
the important part, right?
Yeah.
Okay.
Is it typically enforced by the client? Like where does the enforcement usually happen? Like
no, it's typically enforced by the host, by the
host.
actual LLM application. Right.
But
So
the
that would
host
be like,
is kind of the client, right? Like typically the host is using the client SDK. But like the host is the LLM application, but it ends up like using the client.
Right. The client is the thing that implements the protocol, right? And then provides that information to the host.
Why do we have that distinction then?
Well, this is actually something that I think a lot of people are confused about. And in my mind, the client simply implements the protocol, right? And it's not making any decisions. It's providing the information back to the host. The host is making the decisions or going to the user to make those decisions. But the client itself is simply implementing the protocol. So there isn't, people talk about, well, I have a GitHub Copilot client and a VS Code client. Those are actually sort of the LLM applications, and they are using a client to talk to servers.
Right. So this is obviously semantics. Like, I actually do think you can make analogies between MCP servers and clients and HTTP servers and clients. It's different. Like, there are some key differences. For example, MCP supports standard I/O. It's not common for HTTP. But like, for instance, like, who's the client in the HTTP client scenario? Is it like literally the HTTP client, or is it the thing using the HTTP client, right? Like, it's a little bit semantics. In this case, the host is the thing using the MCP client.
Right. Yep. That's a way to think about it, Stefan. Dan, you want to pop that question from Jose up on the screen? Yeah. So, is this a method for implementing RAG? It kind of is, but as I said up at the top, this is a way of exposing the way to get information to the LLM. So what will go into the context window is information about, here are the tools that I have, here are the things that you can access, and then the LLM will come back and will tell the host, the LLM application, oh, you're asking about this. I see you have a tool that can get this information. Can you please call that tool and then give me the response? And it can even provide the parameters to use when calling that tool. Okay, so all that information flows through the host back to the LLM.
And beyond RAG, I really do want to point out, like, it's definitely not just that, right? Like, you could configure your tools to like send emails or add events to your calendar. So it's also for like agentic kind of workflows. Now, you do want a human in the loop. You might want to like pre-authorize the server to do certain things, right? You can pre-authorize. You don't need to have the human in the loop for like every handler invocation.
Right.
So there's something to consider.
Yeah.
So RAG is one thing that it enables, but it's really generic tools, and it's
more than tools.
It's a plugin infrastructure, right? Like you have some AI system, and you want to enable other people to plug in functionality into your AI system, like GitHub Copilot. That's what MCP enables by having a standard protocol where you can just grab an MCP server that you can plug in then to an existing system.
Yep. Okay, let's keep going. So this is sort of the visual for people who like to look at graphics, right? So you have the host over here on the side, and the host would be something like VS Code or Copilot Studio, Claude, or an IDE, and it uses MCP clients to talk to MCP servers over this MCP protocol. Okay, and the MCP protocol can be either local. With a transport that we call standard I/O. This is the transport that is often used in language server models that are popular in VS Code. Or there's also a remote transport that talks over SSE with HTTP. It actually uses RPC commands to talk back and forth. And there's a new transport that was introduced into the 0326 spec that's called streaming HTTP that Stefan's going to show you here in a little bit. But these MCP servers often run on your local computer so that they can talk over this standard I/O protocol to the host. They can access local data sources, or they can access remote data sources.
But they don't have to, right? They could run remotely as well.
And they can run remotely. They can run remotely as well, and that's specifically that's possible today with the SSE protocol, but even more so with the streaming HTTP protocol that was introduced. Yep.
We got this question that just came up about the difference between MCP servers and plugins in semantic kernel, which is another like a .NET framework for building AI systems. What's the difference?
It works with more than just C# for one, right? And more than just, like more than just our SDK or OpenAI. So it's just standardizing those kind of features.
Yeah, I would say the same thing. It's basically the standard protocol that is, and so and as Stefan said, it's not just C#, right? This model context protocol has been implemented in a variety of languages now. There are SDKs for TypeScript and Python and Java, and others are coming.
Cool.
Okay. What's next there, John? I think we have, yeah. So what about C#? So we've been talking a lot about model context protocol. We have a C# SDK now. Microsoft is actually building that SDK. It's the official MCP SDK. So it lives in the model context protocol GitHub org. It's called C# SDK. You can go there. It was seeded from an open source package called MCP.net. That was originally developed by Peter Peterson, but he, when we contacted him, was very gracious and said, "Sure, let's make this the basis for the official package." And so we incorporated that. That gave us a great head start, and now we are building on top of that. The current version, I think, is 0.10 preview 10, but it's evolving rapidly. There are things happening, we're trying to add new features, make it more usable. So there are occasional breaking changes. Just, be aware this is a preview. Breaking changes can happen. We try to limit them, but they do happen. And our goal is to faithfully implement the MCP spec, right? Now, the spec itself is evolving, as I mentioned earlier, so that's going to involve some change as well. But we're trying to keep things so that people can build on top of this, do real work, but just keep in mind that it's still in preview. It is being used by a number of Microsoft products that are adding support for MCP servers. So it's getting some good adoption. I'm sorry, did someone want to jump in there?
Yeah, sorry, just to speak to how fast we're moving. We're on preview 11 Friday. We released some fixes for Streamable HTTP. So, but expect breaks. I definitely agree on that. We have some ideas, but not anything that should make you afraid to try it, right? Like things that will make it better and should be easy to react to as someone, a user of the SDK.
Yep. Okay. I think we are ready to start some of the demos here.
All right, let me pop over to here. There we go.
Yeah, okay. So this is actually a demo. There are a number of samples inside the C# SDK repo. And the one that I'm going to show you, because I think it really helps to bring home some of the concepts that I talked about earlier, is this thing called the Everything Server. And the Everything Server has prompts, and it has tools, and it has resources all in it. Just to show you a little bit of the code here, this is just the program CS, and we start with adding the MCP server, and then we add a transport, and then we add tools, and we add prompts, and we add resources. All of this very nice, fluid flow of how we add things in ASP.NET. Okay. So let me fire it up here. What I'm going to use is I'm going to use a tool that's available in the MCP GitHub org that's called the inspector. And the inspector will run a server, and then it will access all of the capabilities. It sort of knows all the features that a standard client would be able to expose for a server, and it makes those available in a nice graphical interface. So you can run it with just npx. It's a node package, and you give it the inspector, and then you tell it how to run the server. And since I'm here just in my project, I'm just going to say .NET run. So it's going to start it up, and it's going to say, "Yep, I'm here. I'm listening on this." So I'll click on this, and that. loaded in the other window, but okay, here we go. So we have the inspector started. It knows that it did a .NET run, and now I want to connect to the server. So that's the first thing that you do when you start a server running. You say connect, and there we go. We're connected. There's a little window down here that shows you some messages that are coming out from the server. These are just info messages. And up here across the top, you can see all the things that you can do with this server. And so let's start with tools. This is the most common thing. You can come to tools and you can say, list the tools that are available in this MCP server that I've connected to. And we had a number of tools that we configured in our everything server. I'll just pick this echo tool here, right? And you can have parameters that you pass to the tool. And these are things that are exposed through the client. So the LLM will see that. We'll see that there's parameters that you want to fill in. So we have a parameter here, hello world, and we can run the tool, and then the client will pass that to the MCP server to run. The server will run it. We'll pass the output back, and then that output here we're just displaying it in this window, but that would be passed back to the LLM. Presumably after the host would look at it and say, oh yeah, that looks fine, right? So here's an example of running the tool. You can see all the tools that we have available. There's a print env tool that I could run, and it will just print the environment. Prompts is the next thing, and you can list all the prompts that are available. And here we have two different prompts. There's the simple prompt. You can just say get prompt and it will show you that prompt. There's a content here. Or prompts can also take parameters. So you can have a complex prompt, and we'll just fill in some parameters here. And then we'll say get prompt. And this is the prompt with arguments, and you can see that I've filled in those parameters. And then finally, there are resources. There are static, or what they call direct resources. And so you can see here that if I get a direct resource, it basically just goes and fetches this resource. It's a static thing, or at least it's a static URL that you fetch from, and that will return the contents of that URL. There's a MIME type here, so the contents could either be text or they could be it could be something else. Actually, I'll show you that here in a minute. There are templated resources, and with templated resources, there can be parameters. So here we'll have a parameter, and we'll just pass in 1, and we'll read that resource. And here you see we get back a resource. Again, this is text plain type. But if I picked a different,
it's RNG. We just got to keep trying until we get binary. Like that's how the everything server works.
So I thought it was based on the ID.
I think it is based on the ID, but it precedes it with a random number generator.
Oh, okay. Yeah. So anyway, so once again, these are things that the MCP server can provide back through the client to the LLM, the host application. The host application can then pass those into the LLM to use to answer your questions or to do whatever task you are asking the LLM to do. All right. So now I think I'm ready to hand it off to Stefan to show you some of the new stuff with the streamable HTTP transport.
There
All
are
right.
a couple questions just before we hop on.
Yeah, go ahead.
And then maybe Stefan will answer some of these, but let's see. Like, here's one about what's the difference between importing an open API spec into AI as a plugin versus using MCP?
I think, again, it's just the standardization, right? It's that this is a way of, in a very standard way, providing this information to LLMs that they'll be able to understand. You could just pass in an open API spec as well. Some LLMs might be able to understand that, but it's, I think it's you have a better chance of getting the LLM to understand the MCP prompts and tools.
Yeah, just to like kind of add to what you say, I completely agree. I think before MCP kind of got momentum, maybe a month or two ago, all the other like cloud, LLM providers were copying the open APIs. And recently, you said open API spec as an AI. Oh, yeah, sorry. That's interesting. There's more capabilities. I was reading open AI spec, like, because they had their own way of specifying tools. Okay, open API spec. I understand the question better now. Maybe I don't have a lot to add, but there are some more like capabilities for like sending server to client messages and things of that nature with MCP than you would with just a typical REST API. Sampling is another big feature where the server can actually request LLM output from the host and get information about the user's current session, and like that's going to be hard to do with like open API. And like they're adding more features like as we go that are specific for things that, you know, these LLM client hosts might need from a server. So prompts and all that.
It's been a little while since I've looked at this, but I think like in particular semantic kernel had something around this open API spec support where you could, in addition to advertising to the model plugins or functions from semantic kernel, I think you could advertise APIs using open API specs. I can't remember though if the API. I think the API call still had to happen on the client. Like it wasn't like the model had server functionality for calling those APIs, if I remember correctly. I could have that wrong, but it was another way that I know at least semantic kernel supported for exposing functionality to the model that the model could then decide, hey, I would really like to use that. I'd like to call that function, or I'd like to call that API. Hey, whoever's hosting me, please make that call and then give me the result. But it was specific to how you interacted with semantic kernel, whereas with MCP, it's a standardized protocol so that, you know, when you create a plugin, it's not just a semantic kernel plugin. It's a plugin for any system that supports MCP. You could build an MCP server once and use it with, say, GitHub Copilot in Visual Studio Code, but you could also use it with one of the Anthropic tools or use it with one of the other, you know, AI systems that also supports MCP plugins. And then you can also have I think there's even GitHub repos, you know, informal registries of existing MCP servers that you can just go find one. Like if you wanted to extend your GitHub Copilot experience with some functionality, like, you know, I don't know, telling the weather, you could go get a weather MCP server and plug it into GitHub Copilot, and that just works. It now can pick up those additional tools, those additional resources, and just use them. So that's the difference.
Right. And like just really quickly.
Sorry, I was just going to say the weather sample is one of the other samples that's in our repo.
Yeah, exactly. And just like really quickly, there are like tons of projects out there that like proxy MCP tools from open API specs. That'd be like a fun side project to do with the C# SDK is like read an open API spec, create an MCP server tool, register it, you know, expose it to anything that can call an MCP client. And now you can just point it at any open API.json, right? And like, I'm sure if you search GitHub, you can find that probably written in TypeScript SDK or Python SDK. But this would be a great thing for the C# SDK as a side project. Like it's not something I would think we would build in. We have gotten some issues for that because there's like naturally this kind of, you know, leaky abstraction, right? When you go from one protocol to another. But it's also not that complicated to write yourself. So if you have something that you want to expose to, you know, an LLM that's already defined as an open API spec, then I think that might be a weekend project to just like expose that as an MCP server.
I mean, if you've ever been working with GitHub Copilot and you're like, oh man, I really wish GitHub Copilot had access to this other information or could do this other action, and you're always like, I wish Microsoft or GitHub would just add that. Well, guess what? With MCP, it's the extensibility model now for GitHub Copilot and really any AI system that supports MCP. You can now add a plugin that adds that functionality yourself. So we're going to see some examples of that now. So let me, Stephanie, you want me to share your screen now?
Yes, please. All right. I'm actually really excited for this sample, mostly because my coworker Brennan mostly wrote it for me using SignalR. Like I was supposed, they asked me to demo Streamable HTTP, and we'll get there. But we're starting with the standard IO example that my coworker wrote, Brennan. He's amazing. And you'll see why in just a second. So here we're just going to launch this client, which is using the standard IO server transport that, this is the server. So let's look at the client code really quick. So we're going to launch this client using the standard IO client transport that's going to launch our SignalR server. So you can see you have the launch arguments here. And then it's going to list the available tools, which there will be one, draw a line, and then it's going to ask the LLM to use that tool. So without further ado, we're going to launch this. And since this is like launching the server in the background, you'll notice we had to do the trick that basically all of our README show, which is we're logging the stand error, right? Because the way the client is talking to the SignalR server is over the standard IO pipe. So if we did the normal console logging to standard out, it would corrupt the MCP calls. So anyway, what this is doing, right, is this is creating a standard IO server, which then can send draw updates to this whiteboard demo that that we already have basically as a SignalR sample. And since the client is the thing launching this demo, oh no, I gave away what I'm going to do. Well, we're going to have to draw something else now. So we're going to have LLM to draw something using this draw line tool. That's the takeaway here, right? Is we're going to give it this as a tool, and then we're going to ask it to do stuff. So the client's running. We got like a chat loop here. I hooked it up to Chat GPT 4.1. So I've been testing this with the Christmas tree. The temperature is definitely above 0. So like I have, what should we ask it to draw?
Pokemon.
Oh, really? Are we going to get sued by Nintendo? Okay. Let's try it. Draw. This might be fun. All right. So let's take a look. We have this connected. Sure. Which Pokemon would you like to draw?
Pikachu.
Draw Pikachu, please. I've heard that LLMs work more nicely if you are polite to them, because that's how they were trained and reinforced.
Just good practice anyway, right?
Yeah.
Treating each other. Nice.
Okay. So it drew a curve. It's black. Oh, there's some sparkly lines. Right? That's pretty fun. All right. So we started drawing a Pikachu. So this is all using standard IO. But you can kind of see that this is like inconvenient, right? Like this thing launched with a server like as a sub process, and we couldn't even see like which port it was listening on or whatever. Like to figure it out initially, since this is like Brennan's project, I do what I normally do, and I'm just like, all right, well, I'll go to the server project and look at launch settings.json. You can see I have it expanded. I'm like, all right, here's where it is. But what if I wanted to use HTTP-based transport so I can more easily debug it, right? Like, so now if I have a bug on the server, like I have to do debugger.launch or like attach to a running process, right? So I promise you, it really is easy to make the changes to switch this from basically standard IO to SSE. But I'm working on my laptop right now and I don't trust myself. So instead, I'm just going to show you what the changes would be, and in the right Git extensions repo. So here we added basically the aspnetcore package. Previously, the server.csproj. Let me zoom in here a little, right? So the server.csproj only had a model context protocol preview 11 package. Now we're adding the aspnetcore package, so you can have like an HTTP based server, right? And therefore, if you're using the main, oh no, what did I do? Oh no, okay. Sorry, I don't use Zoom it much. Okay, so anyway, and I think anyway, so you need this if you want to do an HTTP based server. Some people wanted an HTTP listener based server, and I want to tell you that that would only work for localhost, and Kestrel also works for localhost. You shouldn't be afraid of ASP.core. It's nice. It runs all in process. It's much faster than HTTP listener. Anyway,
Stefan, there's a question kind of related to this. Like there's some people that actually aren't really clear on like standard IO versus SSE. Like what is that all? What's the difference? Like what does that mean?
All right, so standard IO, right? So what that is like when you write like, .NET new console app, or you create a new console app to, your, in Visual Studio or what have you, right? Generally what you're doing there is doing console.writeLine. That writes to what's known as standard out. And if you call it console.readLine, that reads from standard in. That is how these LLM clients are communicating with your MCP server process. Is they're literally launching your process sending requests over standard in to be read via console read line, basically. Obviously, a lot of hand waving there. And then the responses are in via console write line, which is simple. But it does make it harder to like debug the server and stuff since you're not launching it yourself. It's actually the client launching it. But it does give the client the ability to like launch it with parameters and stuff. Anyway, I'm really failing with the Zoom it thing. I think it's because I have the touchpad scrolling or something. Anyway,
you need an MCP that controls Zoom it, and we
clearly. So that's it, right? So you can see that this really was like a 10-line change. So all we did is switch.
So that's standard IO, but SSE is server sent events. Like that's a network protocol for like how you like stream results to a client over a network, right? And it's kind of an older protocol, right? It's been around for a little while. I think Signalar
uses it. Yeah. So this is like using double the SSE now. Actually, it's using SSE to connect to the Signalar client and now to the MCP client. But yeah, it's just a way of sending response data in real time to a client. So instead of a client being forced to make a request to receive like a notification or a progress update or whatever, or poll or something like that, basically what SSE does is it keeps the response body stream open to write events, as they're called. And in this case, in the case of MCP, the SSE events, which are written as response chunks, basically, or just response body data for HTTP2, are then read by the client like before the complete response is read. So you're able to like process data as it comes.
So it's the choice there. Like there's also, talking about the different protocols, Signalar wraps, like there's also like WebSocket and other stuff like that. I'm guessing SSE is chosen as kind of the more kind of lightweight, like the chunkiness level of abstraction that you want to talk at.
Yeah, so I mean, this was designed, so this was specified by like the MCP steering committee. I am on the MCP steering committee Discord, kind of stuck in there. But like, I've been contributing. But when they were debating the streamable HTTP spec, WebSockets came up, and they didn't want to support WebSockets because they didn't want to create too much bifurcation of clients. So like it was either going to be SSE or WebSockets, basically. And you're right. They decided that SSE was just a little bit easier to support. WebSockets have some advantages, but like SSE, I think, does the job. Even if it has like worse support for say like binary data and stuff.
The key thing you've missed is standard IO has to be local. Like your client and server have to be running on the same machine, so it's like same process environment to be able to like launch that separate process. Whereas with SSE, it can be off in the cloud anywhere, hosted on Azure, AWS. You don't know, you don't care.
Yeah, very good point. I didn't even say that because like to me that's so obvious. But yeah, very good calling that out. Yes, the web-based ones can run remotely. They don't have to be launched. That also means that you can't control like the command line arguments to launch the thing, but then you could pass query string arguments or whatever if you want to, right? It's just like a different mechanism.
I think there's this question about like, can standard IO servers be hosted in the cloud? The answer is no. Like you need to use the SSE based transport for
you could write a proxy, but yeah, like you could do a standard IO server and then like expose it via an HTTP server. That's another fun weekend project. But like generally, if your plan is to expose in the web, then use this directly. Why would you go through that direction?
A blog post on the .NET blog recently about using Azure Functions as a SSE-based MCP server for remote hosted MCP server implementations that you might take a look at.
Okay.
The URL list for folks that are interested in that potential approach.
Yeah. So I don't know where we are on time. We do have a lot more of this demo. We haven't even gotten to like the stream issue. But if there are more questions, I'm happy to answer them. But yeah, so here we are, right? So we changed the server to call with HTTP transport. I just showed you the diff. It's not that much different before. We call map MCP. right, to control which endpoint we're listening on. And then we changed the client process to, instead of call like the standard IO client transport with the, .net run forward server CS project, you remember that. Anyway, now it just connects to, this is using the SSE endpoint because I'm using the publicly available Preview 11 package, which only supports SSE. There is a PR out now for streamable client support, but I'll show you that in a second because we already have streamable server support. And anyway, so we're just going to run the same demo. But the one thing that we have to do is, before we were just starting the client because it was launching the server. Now we're just going to launch both projects together. And then when we run it now,
that dialogue, I think you need Aspire.
Yeah, clearly, sorry, should have added Aspire. The good thing is, like, the ordering mostly works out because, like, the client, when it connects, will, like, wait a smidge for the server to start listening. So anyway, what should we draw this time to prove that it's working? So now, it's doing a bunch of HTTP. You can see the output from the HTTP server. You can debug. We are debugging, so we can actually put like a breakpoint in. So let's do that just to prove this. Like, without having to do debugger.launch or attach to process, we can just add a breakpoint. And then, yeah, let's ask it to draw something. What this time? Draw
a robot on a skateboard.
Please. With an exclamation point to show that I'm happy and excited.
I should have said please to you, and you would have.
All right, there we go. So we got it. So we have our start. So remember what the LM is doing here, by the way. Like, it can't see what it's drawing. Like, it's just giving us coordinates and colors. And it's actually coming up with some pretty good stuff. I would tell you this. I would not do nearly as well as these LMs are doing, giving these calls. But anyway, let's remove the breakpoint. We'll continue. Let's make sure we're looking at this, though. As soon as I hit continue, it's going to go back. So I'll tab. There we go. Robot driving a skateboard. It's upside down a little bit, I think, but I also don't know.
It's not done. It's not done.
It's not done. What did it say? I'm sure it will offer to draw us more. Oh, you can see the request coming in, right? So this is interesting, right? So the data to the client, which we're not sending much, oh my goodness.
Wow.
Is coming over that MCP SSE endpoint that you saw right here, right? But if you look at the server logs, right, you'll see a lot of basically MCP message calls. That's because SSE, unlike WebSockets, is only in one direction. It's only server to client. So for the client to send additional requests for additional tool calls, it has to make a post to a message endpoint, which is actually, like, the way the client knows about that endpoint is the very first SSE event that we give the client is like, where do you post messages to? So that's that. So this is still the old, like, November whatever protocol SSE, which frankly, for anyone wanting to do remote MCP servers right now, this is what you should be using. You should not be using Streamable HTTP. Streamable HTTP does not actually give you any new features. Like, SSE is already streamable. Like, you can already send progress updates and notification and so forth. Where Streamable HTTP helps you beyond SSE is for hosting on, like, the cloud when you might not be able to maintain state, because this is relying on the post messages basically coming in on the same endpoint as the long running SSE message and going to the same server with the same memory and stuff. And that's not always possible in the cloud. And this is where Streamable HTTP helps. So anyway, let's see if they made any more progress. All right, this is the robot on the skateboard. I'm sure the LM's probably done by now, and it's saying you did it, and we can add details if we want. But I think we got the point for now. So the next step for this demo is to show you what streamable HTTP support could look like, or basically fundamentally how streamable HTTP works. So again, this one's a little bit more involved. This isn't like the 10-line change of the last Git checkout I did. But what I did in this case is, since I'm still using the Preview 11 package, I created a my MCP endpoint that uses the JSON message, RPC message and stuff, JSON serialization types that are defined by just the normal model context protocol package. So you could use these, message types, these DTOs in your own HTTP listener-based streamable HTTP server if you really wanted. So to implement streamable HTTP yourself, right? You first want to listen to the initialized message. And if you get it, you want to send initialized response. And you want to make sure that you're not saying you're using the March protocol, because even though you are, almost any real MCP client will break. They all expect you to put the November 5th protocol, especially the MCP inspector, which Mike was just showing you. But then after you initialize, the first thing the client will typically do is ask for which tools you have available. At this point, I'm just using this draw line tool. So this is using a low-level feature. This is using MCP server tool.create. This returns an MCP server tool, which is an AI function. Maybe. Just kidding. The client tool is an AI function. Should have checked that before I said it. There had been discussions about it anyway. So you'll notice that I'm passing the application services as an option when I'm creating the server tool. That's so when it's generating a schema for drawline, it basically knows the iHub context comes from the service provider and not from the invocation. So it's not going to ask the LLM to provide it a hub context, which the LLM no doubt has no idea how to do. So it will know it comes from the service provider. And then when it does list tools, we're going to serialize basically the JSON schema for that draw line tool. And then when they eventually call it, I manually call draw line for you. So if we add basically a breakpoint here. So now our client, for what it's worth, does not support the stateless MCP yet, and neither does the protocol inspector. So to test this, I basically have to use a branch of our project, but I'm going to start just the server this time, and then basically in this other tab right here, you can see I am running basically that MCP inspector tool that Mike was running earlier, but instead I'm running it out of a branch, that PR339, which I think has been merged, but it's not available on NPM yet. But here is the preview version of the inspector that has streamable HTTP. And so I'm going to connect this to my MCP. And then boom, here, if you look at it, we got an initialization message. If I hit next, right, the method is initialized. And then the next call is going to be to list tools. Maybe if I click list tools, boom. And that's what Mike was showing you earlier. And then the next thing is going to be to call a parameter, right? Whoops, didn't mean to do that. So we can do that again in the MCP inspector, which again, this shows you why I'm telling you to use SSE. The fact that even for the thing that's designed to debug MCP server tools that I have to check out, I have to clone the GitHub repo to try it, just kind of shows you how early it is. But if I do 0, 0,
hey, Stephen,
100, yeah.
I have a demo that we need to fit in here, and you're not seeming to wrap up.
Oh, it's close. But anyway, yeah, so I'll wrap up. I did want to show this meme before I stop sharing my screen. I know I'm part of the problem here, but right, everybody, that is pretty funny. So yeah, I'm just demoing tools. That's what everyone does. But yeah, if we run the tool, then we get the tool call. And as you've already seen, that would draw a thing that you could see with SignalR. And that's streamable HTTP. So that will work even without a stateful session and so forth. Like you saw, I just defined it. If I zoom out a little, I was asked to zoom in for the demo, but in about 50 lines of code, just using a normal minimal API handler to do basic tool calls. just using the JSON DTOs that we have here. And now I've wrapped up. Sorry, Sam, I told you it was long, but yeah. Anyway.
And when do you think the streamable HTTP stuff will become more like commonplace? Like what's sort of the time frame for like that becoming the norm as opposed to the existing patterns?
So the reason the inspector doesn't have it shipped yet is because the TypeScript SDK just got the capability like last week. And so they're kind of reacting to that. I think the Swift SDK has client support. The C# server SDK now has server support. We're about to add client support, hopefully today or tomorrow, earlier this week. So, it's moving fast, but
like weeks, then it sounds like.
I mean, I don't know. Other SDKs are kind of slow on the uptake. And I haven't, like Python and stuff, I don't know if they started. They might. But anyway, like I said before, like unless you're running on like a web form and you don't want to maintain state, SSE has all the capabilities an application developer would be concerned about. It's really only deployment that the streamable HTTP stuff makes any easier.
All right, I'm gonna go ahead and bring up Sam, your desktop, I assume. And,
yes, please.
There you go. Thank you,
All
Stefan.
right. So showing an example of this in practice, what I've done here is I have created a MCP wrapper for .NET Dump. So this is a standard IO server, and I have a file here that defines a whole set of tools, which is basically a subset of the commands that are available for .NET Dump. If I switch over to VS Code in Copilot, I can now go and use this MCP server. So this is, you'll notice from the green icon, this is a VS Code Insiders. This is available to everyone. Just Google it. And this updates daily. So what you get is variable, and what worked yesterday may not work today. So in here, I have configured my .NET Dump MCP, and that has about 40 commands available to it. You want to be in agent mode in Copilot to use this, and I recommend the Claude Sonnet as the LLM. They seem to be doing a better job of MCP calling than the other tools right now. But I can say use the .NET Dump MCP to
So I love this because this is actually showing, MCP server actually plugging into a different client. Like what Stefan was showing before, like technically he owned that client. He could have wired everything together if he wanted to, ignore any protocols or standards. But here you're actually taking something you wrote and plugging into something that the Visual Studio Code team wrote, and actually showing how that protocol now really adds value.
Exactly. In the extended form of my demo, I have Claude Sonnet 3.7 try to draw a Christmas tree, but I wanted to give Sam some time.
So what's really interesting here is like, this is Claude figuring out what commands to call from .NET Dump to analyze it. And I think I actually have a bug in the crash info one that's going to fail and then move on. But yeah, so I haven't taught it about these commands just from the basic descriptions and what it has had in the general training across the internet. It knows considerably more about how to debug a .NET Dump than I or probably the vast majority of developers in the world actually do. And so it is figuring out what chain of commands to execute to do the analysis of that dump. And this shows a really good example of the reasoning that these modern LLMs are able to do. I didn't train it on this data. I'm just giving it back plain text, and it's figuring everything else out. So it has figured out that there is a deadlock going on here and why that is occurring.
Is it right?
Yeah. Oh, yeah.
Always have to ask if it's right when you're using AI. That's still the case.
No,
I mean, just turn the temperature up.
It is able to do deadlock analysis. It's able to do memory leaks, and all the common scenarios that we have, that people have written examples of how to use .NET Dump for, it is really good at.
That's fantastic. And this is written with the C# SDK.
This was written with the C# SDK, so it is. Yeah, I mean, it's each of these commands in here is just wrapping .NET Dump and mapping that into the LM. Yeah, so strongly recommend, if you're going to play with this, use VS Code and Copilot there, and use the Insiders build. It is being evolved, and you get new builds daily with the latest, greatest stuff there.
I think the MCP stuff did roll out to stable. So if you're in Visual Studio Code, I think Agent Mode and MCP went out like earlier this month. But yeah, if you want the latest, greatest stuff, definitely you're going to want to be on Insider, just because this, like if you've been seeing, things are moving very quickly. And you Visual Studio users out there, you know, there are people working on it. It's on the to-do list to get that done for you folks as well. So this is great. Like, this is very interesting to think about, like, what MCP servers could we have for .NET in general. Like, this is for, like, you know, looking at dumps and looking at your logs, looking at, you know, improving the developer experience. I don't know about you, but I'm pretty excited to see what the community comes up with in terms of useful MCP servers that augment and improve what it means to be a .NET developer using GitHub Copilot as your developer companion. Cool.
We had some requests for the code, and I shared that. So that's the MCP or whatever.
Right. And to be very clear, the cool part of the demo, the SignalR part of the demo, was Brennan. And then I forked it to show that little streamable HTTP bit. Yeah, it should show up on GitHub.
So Mike, any call to action here? Like, where should people go if they want to try this? Well,
So if they want to learn about Model Context Protocol, they should go to the Model Context Protocol IO site. I think that's in the links. And then if they want to try to use the C# SDK, the link to that also should be in the links. Model Context Protocol C# SDK. There are samples in there. I showed you the everything server, but there's a couple of other samples you can try out. So give it a whirl.
Awesome. Thank you so much. Thank you, Mike, Sam, Stefan, for all being here and showing us this cool stuff. Yeah, give the new MCP C# SDK a try. Let us know what you think. And yeah, thank you everyone for joining us today. I know we're at time, so we will, I think, end here. But be sure to join us next week for the next community stand-up to find out what's new and latest.
Thanks, everyone.
Thanks, folks.
All right. Thanks.
See y'all later.